Hello guys, in today's grade 12 physical sciences momentum and impulse exam clinic, we are looking at a question paper from the Eastern Cape. This is their physical sciences paper 1 of September 2025. Right, so as you can see here, the total marks for this question is 11 marks. This therefore is saying to us we should spend about 11 minutes on this question. Remember, 1 mark, 1 minute. If you keep this in mind, you will finish your exams on time. All right, let's see. A truck of mass 4,000 kilograms is traveling at 32.17 meters per second to the right on a horizontal road. At the same time, a car of mass 2,000 kilograms is traveling at 25 meters per second in the same direction ahead of the truck, as shown in the diagram below. We can see that the truck collided with the car and the two vehicles stick together and move as one unit. Ignore the effects of friction. Cool. 4.2, in fact 4.1. Why am I saying 4.2? 4.1, state the principle of conservation of linear momentum in words. We say the total linear momentum, okay, so the law of conservation of linear momentum says the total linear momentum in an isolated system is conserved. Okay? In an isolated system is conserved, isn't it? Is conserved. Perfect. So let's see. Next question. Calculate the velocity of the truck car system immediately after collision. I will choose to the right that's positive. Okay, so let me just say the right is positive. Okay, I will choose to the right as positive. Guys, even if you choose left being positive, it's still okay. It's your choice. So let's see. We have mass of the truck plus mass of the car, all in brackets, multiplied by the final velocity of the two because they moved as a unit, equals mass of the truck times initial velocity of the truck plus mass of the car times initial velocity of the car. The truck weighs 400 kilograms. The car weighs 200 kilograms. We do not know the final velocity of the truck car system. So let's move on. We leave the final velocity term as unknown. Once again, the truck was 4,000 kilograms. Its initial velocity was 32.17 to the right, so it's positive, right? Since it's to the right, it's going to be positive. The car, its mass is 2,000. Its initial velocity was 25 meters per second to the left, right? So this becomes 6,000 times final velocity, or 4,000 times 32.17 becomes, what is this? 128,680. This must be 50,000. I want to believe that. This must be 50,000. All right. This must be 50,000. So 128,680 plus 50,000 will become 178. So let's see, 6,000 times final velocity will become 178,680. We divide it by 6,000. Therefore, our answer is final velocity will become 29.78 meters per second. The question did not say calculate the magnitude of the velocity, but rather velocity. So we must indicate direction. It will be to the right. Okay. So remember, we need to spend about 11 minutes in this question. 4.3, is the collision between the truck and the car elastic or inelastic? Sure. So you guys, what did you say? It was inelastic, guys. Okay. It's inelastic. Okay. Guys, when you are not sure of such, you make a quick calculation. Even though the question didn't want you to make a quick calculation, you make a quick calculation where you find the total kinetic energy before collision and compared with the total kinetic energy after collision. Okay, let's go. So this one we can really say it is inelastic without a doubt. Now moving on. Oops. All right, yeah. On impact, the truck exerts a force of magnitude F on the car. 4.4.1. Will the magnitude of the force that the car exerts on the truck on impact be greater than, less than, or equal to? This is using Newton's third law of motion. So it will be equal to. Okay? It will be equal to. Now, 4.4.2, they say 4.4.2, they say state and name a relevant physics law that explains the answer to question 4.4.1. Now to name, right, to name and state. To name, the name of the law is Newton's third law of motion. So Newton's third, it's Newton's third law of motion. Now you need to state it. When you state it, when body A exerts a force on body B exerts the same force, the same magnitude of force on A, but in opposite direction. All right? Or the one that I think it's quite easy to remember. When body A exerts, a force, on body B, on body B simultaneously. Okay, body B, because I know you guys like the word simultaneously. Okay, body B simultaneously exerts an oppositely directed force. Simultaneously exerts an oppositely directed an oppositely an oppositely directed force of equal magnitude on body A. Oppositely directed force of equal magnitude on body A. All right, on body A. So let's read it once again. When body A exerts a force on body B simultaneously exerts an oppositely directed force of equal magnitude on body A. And this is how you answer your momentum questions. With that being said, we are done. Bye bye.